Almost everybody had that one. The answer should be 10. We did have a couple of misses. Just make sure you're going inside the parentheses first and doing multiplication before you do subtraction. That should be 10 minus 9, which is 1. Squared is 1 times 4 is 4. And then 9 plus 4 minus 3 would give you 10. For this one, you have to make certain you start inside of the brackets. And once you're inside of the brackets, you go to the parentheses. And once you're inside the parentheses, you have to do 6 minus 4, which is going to be 2. Square the 2 to get 4. Times 2 is 8. And then 3 plus 8 minus 5 will give you 6. Multiply that by 4 to get 24. Plus 5 and then minus 2 will give you 27. Okay, on this problem there were a couple of wrong ones, I believe, and you have to make certain you do inside the parentheses first. In this case you're going to have 4, and in this one 3. So in each one, square that. For the 4 you get 16, times 3 is 48. And then over here, 3 squared is 9, times 4 is 36. Add these three numbers up and you will get 81. Pick a number from 1 to 5.
Watch me get this right. Watch me get this wrong.
The winning number today is 2. Your homework from last week after the pretest. We have 19 present and 16 had homework. That translates into a percentage of 84%. Here come the answers. They're going to be displayed all at once, so you check your answers, and when you finish, you can come up and show me how many you had right. Remember, this is an algebra or an 8th grade algebra review. So it's not stuff we haven't done. You had this last year in junior high. Your pre-test results. Now this is a pre-test, not a post-test. For a pre-test, it's designed to see how much you already know of the entire course before you take it. So if you had a score of 25%, that means you know 1/4 of the course already before we've already go through it. So that's not a bad thing. Second, you don't lose any points on a pretest. You only gain something. So if you had a 10%, that means you know 10% of the course before you even go through it. That's a good thing. Here are the results, and I'm going to show you the results for all of the classes. In first period, Johnson was the high scorer. And in the top 4 scores of first period were Johnson, Darnell, Bartley, and Ruark. For this period, Kleiber had the high score, and the top 10 were Kleiber, Bruton, Clark, Owen, Stickler, Webb, Hellier, Kegley, Imes, and Hamilton. Baldridge was the high scorer in 5th period, and the top 10 were Baldridge, Blizzard, Boyd, Armstrong, Hammond, Bailey, Perry, Montavon, Garrett, Carver, and Blevins D. There are 11 names because the last 2 people tied for their score. You have a new objective for today. Today's objective is to create equations and inequalities in one variable and use them to solve problems. Here's the first example. There are 60 students going on a field trip. Mrs. Hickman's class has 17 students and Mrs. Bentley's class has 25 students. What equation can we create to solve for the number of students in Mr. Royce's class, who is also going on the trip? Where can we start, Stickler?
17 over 60.
17 over 60. Are we going to have a division problem, multiplication, addition, or subtraction? We could have a subtraction problem, so we could start with 60, and then what do we do? We're going to add 25 and 17. Okay. Now what do I do? Okay, subtract that from 60, and then what? Equals R for Royce. Yeah, you can make it R, X, Y, W, whatever you want. And that is an equation that you could use to find out how many students are in Mr. Royce's class. Here's another thing you could have done. You could have had 17 plus 25 plus X equals 60, and then solve for X. There is more than one right answer on a lot of these problems. Both of these would be right. Here's example number 2. There's supposed to be the word "are" in there. There are 115 students from 3 classes that will eat in the cafeteria today. Class 1 has 43 students. We do not know the number of students in Class 2, but it has half of as many students as Class 3. What equation can we create to represent the number of students in Class 2? A good place to start is, what does this represent? The total. And how would I come up with that total? What operation is taking place? Addition. Yeah, so we're going to, how many different things are you adding together? 3 classes. So we have Class 1, Class 2, Class 3, and the total is 115. Remember, this is Class 1, Class 2, and Class 3. What can I put in the blank for Class 1? 43. What can I put in the blank for Class 2? Yeah, we can put in X, because we do not know the number of students in Class 2. But we do know that Class 2 has half as many students as Class 3. Therefore, what is Class 3 in relation to Class 2? How? X times 2, or 2X, right. If Class 3 has twice as many students as Class 2, then we multiply Class 2 by 2. And since it's X, we come up with 2X over here. Are there any questions about how we arrived at this spot? Okay, well, if you leave it like this, I would take that for now. You could also do this. What is 1x plus 2x? 3x. So you could write 43 plus 3x equals 115. That's another way you could express the equation. Try this one and see what you can come up with. There are 3 buckets that contain apples. Bucket 1 is unknown, but we do know that bucket 2 has twice as many apples as bucket 1. And bucket 3 has twice as many apples as bucket 2. If there are 70 apples in all, what equation can we create to represent the number of apples in each bucket added together? There are 3 buckets that contain apples, and if you had read all the way through the problem with me, you will know that the total of everything is 70. So if I have 3 buckets and there are 70 apples altogether, what operation am I doing throughout the problem to get to 70? Adding, yeah. And how many things am I adding? 3. So there's 1, 2, 3, and the sum is 70. And this is bucket 1, bucket 2, and bucket 3. Okay. Bucket 1 is unknown, so what do we let it be? X. We do know that bucket 2 has twice as many apples as bucket 1, so what do I write in here? 2x. And bucket 3 has twice as many apples as bucket 2. 4x is right. I've moved something here a little bit, but it should be 4x, yes. If you're going to have twice as many apples as bucket 2 is 2x. If I multiply bucket 2 by 2x, I get 4x. If you have this it would be right. Also, if you have this, what is x plus 2x plus 4x? If you put 7x equals 70, I would also take that. A class of 30 students is going on a field trip. There are twice as many boys as there are girls. What equation would let us represent this scenario? A class of 30 students is going on a trip. There are twice as many boys as there are girls. So we know we have boys and girls. What operation do I have to do with boys and girls to arrive at 30? You have to add them, yeah. So I have boys and girls, and we're going to keep the boys here and the girls there. There are twice as many boys as there are girls. For the future, here's an indicator you can look at to help you out to figure out which one you should just let be X. There are twice as many boys as there are girls. As there are girls means it's just going to be a variable, unless you've already indicated something about girls earlier on in the problem. So girls should be X. What should boys be?
2x.
2x. So here's one equation you could have. What's the other equation I could have?
3x.
3x equals 30 is another one. And you could also have x plus 2x equals 30. The mid-class quiz. I need the exact answer, not the expression. The sum of 6 and the quantity squared of the difference of a number and 2 is 22. What you would do with this is 6 plus something is 22. What do you add to 6 to get 22? 16, right. So this whole piece right here must equal 16. What do I square to get 16? 4. So that means that the inside of the parentheses will be equal to 4. 6 minus 2 would be 4, so the answer is 6. Here is example number 3. A group of 76 people are going to tour a factory. No more than 20 are allowed to tour the factory at any one time. What inequality, and that's the key word, inequality, which means you're going to have this, 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 or this in your expression, would best represent the number of groups that would have to be formed. So you have 76 people that go visit a factory, but there's only 20 that are allowed to go through the factory at any one time, so everybody else must wait. So you have to have more than one group. Give me a starting point for this problem. What could I start doing first?
Divide 76 by 20.
76 divided by 20, yeah, because if you can only have 20 in a group, if you divide 20 into 76, that lets you know how many groups you could have. But remember, we need an inequality. What could I let represent the number of groups? Do we know, even before we do this calculation, do we know when we start the problem how many groups we need? No. What can we let groups be? X, okay. Now, we know that if we do 76 divided by 20 on a calculator, we come out with 38. We come out with 38. Or not 38. 3.8, yes. 3.8. Can we have 3.8 groups?
No.
So how many groups would they need?
4.
They would need 4. That's the answer to the problem, but we don't need the answer, we need the inequality. That's right, he's got it. It should be greater than or equal to the number of groups that's needed. If it's less than, then you don't have enough to accommodate all of the 76. 76 divided by 20 greater than or equal to x. I think in first period, if I remember right, not that this means anything to you, but I may have written less than or equal to for them. So I have to go back and fix that. But it is greater than or equal to x. Example number 4. John and Joe both have some money. Joe pays 50% tax on his money, and John pays 75% tax on his. After taxes, they have a combined $400. What equation would let us find out what each originally had? They have a combined $400. What operation does that mean? Addition, yeah. How many things would we be adding? 2. So this plus this equals 400. Now John and Joe, we'll make this John, and we'll make this Joe. John and Joe both had some money. But Joe pays 50% tax on his money. What can we let represent John's money before he paid the tax? X. What can we let represent Joe's money? Y, that's right. 50% is what as a fraction?
0.5. Oh,
1 over 2. So if Joe pays 50% on his tax, what would we do to Joe's y variable to get what he paid for tax? 1/2 y. And John pays 75% on his. What is 75% as a fraction? 3/4, yeah. So 3/4 x plus 1/2 y equals 400. Another way you could have written this is 0.75 x plus 0.5 y equals 400. These problems are the exact same problems that are the examples and the practice problems from today's class lesson. Now, most of these we went over, especially the last two with number 6. 7 and 8 we didn't get to, but you should have an idea by now of what to do. Go back through each problem, set up the equation just like we did here in class, the exact same one, but see if you can find the answers for each one as well. Not just the equation, but see if you can find the answer.